Hello, and welcome to the Univar Solutions Flex Forward series of webinars, focusing on plant-based products and applications. Today, we will discuss all things oat milk. We will review the market for plant-based milks, focus on the biggest opportunities in this exciting and exponentially growing market segment. We will discuss the manufacturing process for fast market development. And of course, we will taste our demo kits of high, medium and low sweetness oat milks. We will also have an opportunity to pose live questions to our experts. And I'm delighted to be joined today by a fantastic lineup of presenters. Daniel Maley and Alan O'Donnell of Univar Solutions, and Yannis Samakidis of Novozymes. With this, I hope you have your oat milk tasting kits ready, and let's get started.
Good morning, everyone. Now I'm going to introduce you to Novozymes. Novozymes is the bigger enzyme producer in the world. As you can see in this slide, enzymes are used in many products we consume or we use in our daily life, like drinks, like beverages, while in the fuel we use to drive our cars, washing our clothes, in all sorts of products, enzymes are present to improve their quality. Now, a few words about the numbers behind Novozymes. Novozymes is based in Denmark. It has more than 6,000 employees, but it operates around 130 countries in more than 30 industries. And it has a turnover last year of 15 billion DKK approximately. And what is very important also to remember is that Novozymes is a leader when it comes down to innovation. It has more than 6,500 patents in place. Now, what are enzymes? Enzymes are biological catalysts in the form of proteins. They're found in nature, in every living organism. We also have them in our body, in our saliva, for example. They're fully biodegradable. They're not living organisms. And the first time that we started using them in an industrial setup was in malt in the brewing industry. Now let's go a little bit more, pay more attention to the oat drink market. As you probably already know, this is a fast-growing segment. You can see here how it grows in Europe, almost like 30% year after year. But we expect it, and it has already been growing in other regions like North America, but also in Asia. If we also look at the broader picture and focus on the plant-based market overall, we expect it to sharply rise by 2030 in the incredible amount of 450%. That's wow when it comes down to growth. Now, if we look a bit more on the sustainability side, and here we have an example comparing how much CO2 is emitted by consuming 1 glass of dairy milk versus 1 glass of oat drink. You can see on the left-hand side that is a huge difference on the amount of CO2 emitted, which of course is better understood when we convert that into kilometers of car drive. So if you just drink 1 glass of dairy milk a day, then it's like driving your car for more than 1,200 kilometers when it comes down to CO2 emissions, while with oat milk is less than 400. So quite a sharp difference for those that are, and I hope all of you are, all of us are actually, we care for the environment. Now, when it comes down to water consumption, again, there's a big difference. You can see here what happens when you consume 1 glass of dairy milk. It's like a consumption of 45,000 liters of water, while oat milk is only down to 2 or 3. If we were to convert that into showers, it's like taking 700 showers by just consuming a glass of dairy milk, while oat milk is less than 10 or 20, very, very low water consumption. So that really speaks very well on the sustainability side. But of course, it's not only about sustainability. As you know, taste is king, and this webinar is all about taste and how you can control the sweetness profile by using enzymes. To demonstrate how you can control sweetness, I have produced 3 oat drinks in Spain, a local producer, using the same raw material but different combinations of enzymes to generate different sweetness profiles. All the enzymes used in these drinks that you have received are suitable for organic products. And of course, there are many more combinations in the sweetness profile you can achieve by using our enzymes. These are only as to be used as a demonstration of our capabilities. And also, I would like to give you an idea of how the oat drinks are produced commercially. And for that, we have put together the following video from some trials we did in Germany. After that, Alan will take us through a lab setup and show in more detail how you can use Novozymes enzymes to control viscosity and sweetness in your oat drink. Today I'm at GEA Test Center. GEA is one of the leading manufacturers of equipment for the food and the beverage industry. And I'm going to show to you how you can make a great tasting oat drink.
We mix the flour with the water, where we here use some kind of test equipment, but in bigger scale using also GEA equipment for continuously mixing, where we mix warm water with flour.
Then we add an enzyme, BAN, that breaks down the starch in what we call the liquefaction stage. That helps to adjust the viscosity of the drink. Then we add the second enzyme, fungemil, to make the drink sweeter, to adjust its sweetness, and this is called the saccharification stage. After that, the slurry is moved to the decanter, where we separate the solids from the liquid. And then the liquid is moved to the next step, which is the formulation, where salt and sunflower oil is added, followed by a pasteurization step.
We tested today different setups for enzymes. I've seen that the decanter and the process as it is tested in our test center is working quite good with all the enzymes and additives. We have seen some changes, some differences in the products, and by that we can actively react to the needs of the customer. What we have here in our test center is the CF1000, our test decanter for production of dairy alternatives, so plant-based drinks, which is specially designed for hygienic applications to get it cleaned, to get a safe production in industrial scale and also on test scale.
All these stages were very successful. We learned a lot, both on the process side, but also on the product quality side. And I'm sure with these learnings, we'll be able to fine-tune our service to our customers. So it was really 3 very great days to be at GEA.
There is a variety of raw materials available as a starting point to make grain-based beverages. Today, we will be looking at oats, but there is no reason why other cereal grains could not be used as a raw material. From an oat perspective, you can choose from natural oat kernels, dehusked oat kernels, or dehusked oat flour. Irrespective of whichever raw materials you decide to start from, exogenous enzyme technology can support you to develop the finished product that you want, tailored to your end market requirements. This can include modifying the viscosity, taste, and sweetness levels. Today, we will look at a standard oat milk production process using oat flour as our base material. Here you can see an overview of a standard process. I will quickly talk you through this process before we go back and look in more detail at the 2 main sections where enzyme technology is used to modify the taste and texture. These steps are called liquefaction and saccharification. Firstly, we create an oat flour slurry by mixing oat flour and water in an approximate ratio of 1 part oat flour to 5 parts water. Our first enzyme is added at this point before heating to between 70 degrees Celsius and 80 degrees Celsius. The temperature is held for 30 to 60 minutes to allow full liquefaction to take place. Now we cool our solution to 60 degrees Celsius before our next enzymes are added. This addition takes place at 60 degrees. Again, we hold for 30 to 60 minutes. Centrifugation ensures good separation of the insoluble and soluble components. A product with inadequate decanting can have lower shelf stability in both mouthfeel and off flavor, so this step is very important. The addition of salt at 0.1 to 0.2% will improve the flavor, and vegetable oil at 0.8 to 1.2% with high shear mixing and homogenization can sustain and stabilize a brighter opaque appearance and rich mouthfeel. The finished formulated beverage should be thermally processed for microbial safety and stability according to common heat treatments, followed by packaging for distribution. Oat beverage production steps can be mimicked on the benchtop during the product development phase using an experimental apparatus that can maintain agitation and mixing, consistent temperature control, and realistic times for heating and cooling between steps. You can use a Thermomix for benchtop development, or as we will demonstrate in our kitchen in Istanbul, we've used a simple water bath. We start with oat flour and water, which are blended and mixed together to form a slurry. For the purposes of this demonstration, our oat flour slurry is divided into 4 equal parts. We will have 1 control and 3 test variants to represent the 3 oat beverages that you should have received for our tasting session a little later. Now, we transfer the 4 samples to a water bath, which has been heated to 70 degrees Celsius. Test samples 1, 2, and 3 are inoculated with 0.2% of BAN480L. BAN480L is an alpha amylase that hydrolyzes the alpha-1,4 glucosidic linkages in starch polysaccharides. In an industrial setting, it is important that we add BAN480L prior to gelatinization to avoid a buildup of viscosity. We gently stir the enzymes to ensure thorough mixing and let the magic of enzyme hydrolysis take place. Let's take a look at what is happening at a molecular level. As you know, starch is produced by most green plants for energy storage. All starches are made up of 2 different polysaccharides, amylose and amylopectin. Amylose consists exclusively of glucose molecules linked together through alpha-1,4 glycosidic bonds. The number of repeated glucose subunits is usually in the range of 300 to 3000, but can be many thousands. In simple terms, this creates long linear chains. Amylopectin, which makes up the vast majority of oat starch, has a notable difference from amylose. Again, we see a large number of glucose molecules linked together through alpha-1,4 glycosidic bonds, creating long chains. But in amylopectin, we also see the prevalence of alpha-1,6 glycosidic bonds, which results in branches. Amylopectin contains a large number of glucose units in the range 2000 to 200,000 as compared to amylose. Starch, in the presence of water, gelatinizes when it is heated to approximately 65 degrees Celsius. This process involves the starch granules swelling as they absorb the moisture in the food system, which manifests as an increase in viscosity. Our BAN480L alpha amylase hydrolyzes both amylose and amylopectin into dextrins, which results in the starch granules losing their structural integrity, and this causes a reduction in the viscosity of the solution. In addition, the beta-glucanase activity present in BAN480L hydrolyzes beta-glucans into smaller units. Here we see our control, which has gone through the gelatinization process and has had no enzyme addition. Clearly, a very high viscosity has developed. Now we see one of the test samples that has been dosed with BAN480L. I hope you can see that the viscosity has been completely broken down, and now we have a high solids, low viscosity solution. We have now reduced the temperature of the solution to 60 degrees Celsius, and we are ready for the addition of the next set of enzymes. Test sample 1 is inoculated with a further 0.15% Fungimil 800L. Fungimil is an endoamylase that hydrolyzes alpha-1,4 glycosidic linkages, producing predominantly maltose. Test sample 2 receives a further 0.8% amylase AG300L. Amylase AG300L is a glucoamylase that hydrolyzes alpha-1,4 and alpha-1,6 glycosidic linkages at the non-reducing end, reducing glucose. Let's look at this on a molecular level again. Remember, BAN480L has already hydrolyzed the long-chain polysaccharides of amylose and amylopectin into short-chain dextrins. These dextrins will not contribute to viscosity, but equally will not contribute to the sweetness levels of the finished product. The addition of fungamil reduces these dextrins further into disaccharides called maltose. Maltose has a sweetness level of approximately 0.4, meaning it is approximately 40% as sweet when compared with sucrose. By using BAN and fungamil together, we have successfully hydrolyzed the oat starch into glucose maltose and other small molecular weight dextrins that yield a mild sweetness and pleasing mouthfeel. The addition of amylase AG300 reduces these dextrins further into a monosaccharide called glucose, the building block of starch. Glucose has a sweetness level of approximately 0.8, meaning it is approximately 80% as sweet when compared with sucrose. By using BAN and amylase together, we have successfully hydrolyzed the oat starch into predominantly glucose that yields a sweet product and pleasing mouthfeel. With increased sweetness, this option could be suitable for product concepts such as flavored oat beverages, a coffee whitener, or as a base to a cultured product. Even using the most basic of laboratory equipment, I hope you can clearly see how the use of exogenous enzyme results in a significant reduction in the viscosity of a cooked oat slurry solution. We'll get to the tasting a little later in the session. So, to recap on how to produce each of the three variants you will be tasting a little later, to produce a low sweetness product, we reconstitute a heat-treated oat flour with water in the ratio of between 1:4 and 1:6. We cook this slurry to between 70 and 85 degrees Celsius to gelatinize the starch. BAN480L is added at a concentration of 0.2% to ensure liquefaction of the starch. After 30 minutes, the solution is ready for centrifugation, which separates the insoluble and soluble components. Formulation is the addition of salt at 0.1 to 0.2% to improve the flavor, along with vegetable oil at 0.8 to 1.2% under high shear mixing. Finally, homogenization, UHT pasteurization, and packaging ensure a stable product over shelf life. To produce a moderately sweet product, we reconstitute our heat-treated oat flour with water in the ratio of between 1:4 and 1:6. We cook this slurry to between 70 and 85 degrees Celsius to gelatinize the starch. BAN480L has been added at 0.2% to ensure liquefaction of the starch. Our solution is cooled to between 55 and 60 degrees Celsius before the addition of fungamil 800L for saccharification. From here, we proceed exactly the same as in the first scenario, with centrifugation, formulation, homogenization, UHT pasteurization, and packaging. This allows us to create a product with similar levels of sweetness as regular dairy milk without adding any sugar or sugar supplements to your oat milk alternative. Finally, to produce a sweeter product, we follow the similar process as before. We reconstitute our heat-treated oat flour and water in a ratio between 1:4 and 1:6. We cook this slurry to between 70 and 85 degrees Celsius to gelatinize the starch. BAN480L had been added at 0.2% to ensure liquefaction of the starch. Our solution is cooled to between 55 and 60 degrees Celsius before the addition of amylase AG300L for saccharification. Hopefully this looks familiar. We process as before with centrifugation, formulation, homogenization, UHT pasteurization, and packaging. In this scenario, we have produced a product with a higher level of sweetness.
So good morning. Today I'm here to tell you about some of the other ingredients that Univar Solutions have in their portfolio to support you with your oat milk development. So oat milk, as described earlier in the webinar, is made from oats or oat flour, water, salt, and enzyme technology with maybe a little bit of oil. So these can give you a really nice oat milk, but they also form the foundations to build upon to really optimize your oat milk to give you your own desired or bespoke recipe. Today I'll be talking about three of the key pillars, things that we're asked about all the time when it comes to oat milk development. So we'll be focusing on nutritional fortification, taste and texture. Fibre enrichment is a very common trend across all applications and industries. We can support with fibre enrichment by using our fructooligosaccharides or our inulin. These are prebiotic fibres and they can really help you achieve that fibre claim if that was what you were looking for. Protein enrichment can be achieved by using our proteases as discussed earlier. But if you needed something else, if you wanted to add a pulse protein concentrate or isolate for fortification, but also for texture and viscosity, we can also support you with that. Calcium is a key mineral when it comes to the fortification of oat milk. We know that it's something that oat milk is lacking versus the dairy equivalent. And most oat milk brands, especially the leading brands, are fortifying with calcium. Luckily enough, we've got a few different ingredients within our portfolio to support that. We've got calcium citrates, calcium phosphates, and calcium carbonates, which all play their own part in delivering that functionality and that health claim. We also have some partners and some suppliers that can achieve a bespoke blend for you. So if you needed some bespoke B12, different vitamins and minerals together in one mix, you could reach out to us and we can support you with that. Now, taste is very important as well. And we know that the enzyme technologies that we use can really help you tailor that sweetness perception and sweetness taste within your recipe. But that might not be everything for you. You might want to flavour your oat milk, and therefore we would introduce some of our natural flavourings. That could be fruit flavouring, that could be vanilla, chocolate, whatever you needed. But also thinking outside the box and thinking of oat milk not just as a milk or a beverage. Oat milk is used now as an ingredient for many different recipes. I'm thinking more about the savoury route here. So we know that oat milk really helps with creamy sauces, creamy plant-based sauces, for example, a plant-based bechamel. So we have vegan dairy flavours that can be used along with your oat milk base. You can add those in. They could be cheese, they could be cream, they could be butter. It could be anything along those lines. And that's something that we can offer from our ranges. If you didn't feel like the sweetness you were getting from your enzymes was enough and you wanted to add a little bit more, we have, and maintain the natural health claim, I should say, we still have our stevia range of natural flavourings. So they're modulation technologies, very innovative, with no added sugar, but do add extra sweetness. Another ingredient that I haven't mentioned earlier is the prebiotic fibre fructooligosaccharides. We know that that does give also a little bit of sweetness as well, so that can help the taste. Texture is important, and enzymes play a big part in the texture, especially the viscosity. But we also have some other ingredients that we can add in to tailor your recipe just for you. Gelling gum works really well in beverages, as we know. Very heat stable, great stabilizer, and can help with the mouthfeel. Dipotassium phosphate in particular is widely used with the leading brands of oat milk. What we know about this product is it's a really good emulsifier, and it really helps the opacity of that product as well. So it's key when you're making some oat milk. If you felt like you didn't have the mouthfeel that you desired, you wanted some creaminess very close to dairy milk, then we have some co-texturizing fat-mimetic starches. So what these will do is they will not bring any viscosity to the product, but they'll coat the mouth and they'll give a really indulgent and creamy mouthfeel. So I've talked you through a lot of exciting ingredients there. If you would like more information, if you would like some samples of these, please reach out to me or a member of your team in your region, and we would be happy to help. Thank you very much for your time.